In this video, we are going to be doing two examples for joint variation. Joint variation is when a variable, let's say quantity Q, is proportional to two or more other variables. We say that Q varies jointly with these quantities. In joint variations, there can be combinations of direct and or inverse variations may occur. So what I want you to think about this is, so let's say we have y varies directly with an x, but also with a variable z. We could also y varies directly with x, but inversely with z. So we're going to have combinations of this two, direct and inverse, okay? So let's see this example first. The example says the horsepower, all right, the horsepower, HP, that a shaft can safely transmit varies jointly. So we know that. Ooh, varies jointly, kind of large. Maybe let me make it smaller because, okay, varies jointly with its speed in revolutions per minute and the cube of its diameter. All right. If a shaft of a certain material, 2 inches in diameter, transmit 36 horsepower at 75 revolution per minute, what diameter must the shaft have in order to transmit 4 horsepower at 25 revolutions per minute? So that was a lot. Let's identify our variables, okay? So we know it varies jointly. Okay, so the horsepower is our dependent variable. And the horsepower depends, okay, on the speed and the cube of the diameter. Oh, my bad. The cube of the diameter. Okay, so this is varies jointly. And the horsepower, so the horsepower, I'm going to start with this first. The horsepower with my K varies directly. Okay, it doesn't say directly. We can see that. But as the speed increases and so does diameter, the result will be the higher speed for the horsepower. So we are both are increasing, all right? So we're going to have the X and that Z value. Using the variables that are in the problem, I am going to say the horsepower is H, the K that I must find, and the speed I am going to use S, and I am going to use D, but is cube, so that means to the third power for the diameter. Okay, now in the second sentence, I am giving all the information I need to find the K value, okay? All the information I need. So I go ahead in here and I say horsepower 36. I need to find K. What is the next one? The speed says 75. And the diameter is 2 inches cube. Okay. So all of this is what I'm doing here is to solve for K. When you do 2 cube gives you 8 times 75. If I'm not mistaken, that is 600 K. Divide both sides by the 600. Our K value simplifies to 0.06. Now that I have my K, I can rewrite my model. So H equals 0.06 as the cube. Okay. Now I go to the final sentence. What does they want me to find? What diameter must the shaft have in order to transmit horsepower, a 4 horsepower at 25 revolutions per minute? So I am looking for the diameter. So I am substituting 4 for the horsepower. I'm going to put everything in parentheses because it's better. That way I can see my multiplication happening. 25 d cubed. Okay. So when I multiply all of this, I have 4 equals 1.5 d cubed. I am solving for d, so I'm going to divide both sides by 1.5. Now, when we have an application, it's important for us to not round within the problem. So I am going to keep this just like this. Now I am solving for d. So I am going to do the cube root of both sides. Okay. Oops, don't want to change color. So then the cube root of this rounded. An example like this will ask you to round to 2 decimal places. So then that will be 1.39 inches because we are looking for the diameter and the diameter is in inches. All right. So first we read the problem, we identified that it varies jointly. Based on the application, we can see as the diameter increase, as the speed and the diameters increases, our result our both variables are increasing. All right. And we created our skeleton model. We found the K value. From there, we went to the last sentence and found what they were looking for, which was the diameter. Now let's see another example. Okay, so the example says the electrical resistance R of a wire varies directly with the length L of the wire and inversely with the square of the diameter D of the wire. So we can already see that we are working with a joint variation because we have the electrical resistance, then we have the length, but we also have the diameter. So if I try to put my skeleton model together, I'm going to have K. So notice how it says directly with. So I'm going to have my X, but then it says, so we have directly with, but also inversely with. All right, so that is the 2 more variables. So I have 2 instead of just 1, therefore this is joint variation. So now I'm going to, for electrical resistance, we have R. For the length, we have L. And for the diameter, we have D. I'm going to use those variables. So I have R equals the K, the length, over D. But D is square. Important. So this is D squared. Okay. Now I go to the next sentence and they're going to give me the information that I need in order to find the K. Taking that information, I am going to substitute it. So it tells me the resistance is 1.25 ohms equals, I don't know, K, times, I said the length, says 4 meters. Nope, that's not it. Oh, 432 feet long. 432 feet long divided by the diameter. So it says 4 millimeters in diameters and that's square. So this is going to give us equals 1.25. Let's see, I have the work here. It's going to give us some decimals, so we're just going to keep it as the fraction over 16K. Cross multiply, so multiply 16 on both sides. And then divide by 432. So K equals 5 over 108. Okay. So in this side, I multiply both sides by 16. That cancels. Okay. So then 16 times 125 equals 432K. Then divide both sides by 432. And the K is by itself and we have found our K. Now taking the K value, we are going to replace it with our skeleton model, which will leave us with our actual model to use. So I have 5 over 1 over 8 L over D squared. Yes, we have a fraction, so we have a complex fraction. Nothing wrong with that. Absolutely nothing wrong with that. Okay, something we can work with. So this is the model. Now we're going to go to the last sentence and see and answer the question. So find the resistance if the wire is 282 feet long with a diameter of 3 millimeters. Okay, so I am looking for R. Okay, so I do not know R. So I have 5 over 1 over 8 times 282 divided by a diameter, 3 millimeters. So I have 3 square. How we're going to do this? First, you're going to multiply 5 times 282. Once you multiply that, you're going to divide it by 108. That answer you will divide by 9 because 3 squared is 9. Once you do that, you are going to get 1.4506172 and maybe a few more. But the directions for this will say round to 2 decimal places. So that will be 1.45. And we are looking for the electrical resistance, and the units for that is the ohms. Okay? So then that is our final answer. Ooh, boom. So if you see this problem, okay, the work is all over the place. But notice the first thing we did, we read the problem completely. Cool. The second thing we did, we identified the type of variation that we have. Notice that the electrical resistance is working with 2 variables, not just one. So that lets me know that it's joint variation. Okay? So I know I have joint variation, but what combination of it? The problem clearly states the electrical resistance varies directly with the length and inversely with the diameter. So I make that connection, put them together. So now that gives you your skeleton model. The second sentence gives you the information that you need in order to find the K value, which we did. So we found our K. Once we have our K, we take that information and put it together. So we found our K. Let me get this. So we found our K. We take that information and put it into our skeleton model. And now we have a model that we can answer any questions regarding the resistance, the length, or the diameter. The question that they asked us was to find the resistance, the electrical resistance, given specific information, which is what we did. All right.